Okay, well, thank you for everyone for joining me for this Intro to Knowledge Graphs meetup for Hacktoberfest 2020. I will go ahead and start presenting. My name is Chris Woodward. I am the Developer Relations Engineer at OrangoDB, and that kind of means my day-to-day consists of everything from working with different teams on development projects to figuring out better ways to have training and engaging with the community to make sure that working and learning OrangoDB is the easiest and most fun that it can be. Definitely feel free to reach out to me on Twitter or Slack with any questions you have or just to keep in touch. And today we're also joined by David Costa, and that he is with reKnowledge, and they're actually going to give us a demo of a real world use case of knowledge graphs. So we're going to take a look at some of the concepts and get introduced to the idea of knowledge graph, and then actually get to see one in action, which is pretty cool. And so to get right into it, some of the topics that we're going to cover are a quick overview of what is a graph database, and then we'll take a look at defining what actually is a knowledge graph. And then from there, we'll just start taking a look at some of the concepts involved. And this should all be a very basic introduction level. And this talk will actually be followed by a more in-depth written tutorial that we're working on that will be a part of a series of knowledge graph tutorials that will help the beginner go from just figuring out what a knowledge graph is to being able to actively work with them and see how that looks like in OrangoDB. And then at the end, we'll have an interactive notebook. It's a really small, quick demo notebook of just looking at what it looks like to put a triple into OrangoDB in one method, and then you'll have an opportunity to submit a PR with this notebook of just maybe a different method that you have, or just showing that you know how to pull out a snippet from the DBpedia dump that we'll send a link around for as well. And that'll get you a pull request for Hacktoberfest and get you one step closer to your shirt. All right, so first things first is, what is a graph database? Simply put, a graph database consists of documents that describe relations within data. That's a very, very simple definition of it, but that is sort of the gist of it. Graph databases are typically NoSQL databases. They consist of vertex and connecting edge documents, and depending on the database or how they're structured, they can be directed or undirected. Sort of a good example for that would be like a directed tree graph. So like a DAG graph would be an example of like an organization chart. So starting from the CEO and then navigating down. That's sort of a one direction thing, like the CEO and then through the hierarchy there. Whereas you might have an undirected or a bi-directional direction for the graph. And you'll see these in use cases such as like transit, where you have routes that, from one city to another, or like with our airports graph, from one airport to another, that you can take flights back and forth between airports. There's not one direction only. And then finally, property labels is something that you can do specifically with property graphs, which is what you'll find in OrangoDB, where you can define labels and describe the data involved in the graph a lot more as well. Here's an example of a graph database. This is just a quick view of one of our IMDb data sets that we use. This is showing movies with the comedy genre and some of the movies connected and the actors connected to those movies. And this just really shows one of the nice use cases that you can have where you can take this data, and because it's all connected through its edges and vertices here, the nodes, the purple dots there indicate the nodes, while the green lines are the edges connecting them. So we could look at something like movies that Bill Murray has acted in, like we have here with Bill Murray in Kingpin, shows that he acts in Kingpin. And then you can continue sort of doing a graph traversal out, looking at all the movies that are connected to Bill Murray, and then from there, maybe other actors that are also connected to those movies that Bill Murray has starred in, and sort of start doing some of these more interesting queries thanks to the graph nature of the data. And just some use cases for graph databases. There's a lot out there, but some of the big ones would be a recommendation engine, something like looking at when a customer is making a purchase, what other customers who made that purchase, what did they buy next? And now maybe we can recommend it to this customer. Social networks of any kind really are a really natural way to represent data as a graph. And so just like a social network of friends and finding similar interests and just these sort of, again, kind of even going into the recommendation, being able to recommend friend or activities based on what friends of friends are doing and this sort of thing. Knowledge bases, which is exactly what we're kind of looking at today, is a knowledge graph, linked data, connected data, and how you can describe the relationship between things in that knowledge base to make use of it. Machine learning is a really great use case for graphs, as a big part of it is looking at pattern matching and looking at the connectedness between things in a graph database is a really natural view of that. And if you are interested in machine learning, we also have a series on machine learning for beginners as well that's introducing some of these concepts of machine learning using Orongo ML and Orongo Pipe. So I highly suggest checking that out just on our website, orongodb.com. And we're coming out with new posts for that every 2 weeks as well. So if you'd like to learn just more about some of the basics of machine learning, that's a really good resource to go with also. Finally, fraud detection, watching transactions come through. We actually have a great fraud detection example with Oasis. If you have an Oasis account or not, you can sign up as well with a 2-week trial. But the fraud detection shows the way that you can monitor transactions. And when you're looking at a higher view of these transactions, you can start to detect which ones seem a little fishy, and some cool ways that you can use that to catch the bad guys. All right, and so some of the things that you'll want to, if you're not already totally familiar with graphs, I would really highly recommend starting with the graph course refreshers. This is what we recommend for if you're new to graphs and you're new to OrongoDB. This will take you from very brand new to writing advanced graph traversal queries. This uses our airports and flights data set, so showing flights from real airports throughout the US. And here are some additional graph resources. I'll send this out with the recording of the video so that you can have access to all these links. The graph course refreshers I mentioned, the what is a graph database. This was a really quick summary of this article. So if you're interested in some of the specifics of what makes up a graph database, I really recommend going to this what is a graph database page. And of course, our training centers has a lot of free training resources. And if you're more into the video format, I've also released a little over 2.5 hour getting started with OrongoDB course on Udemy for free as well, that kind of covers the full spectrum of OrongoDB features. So definitely check those out. And like I said, I'll be passing this out with the recording. Okay, so that was a quick run through of graphs. Now let's kind of get into the main thing that we're doing here is knowledge graphs. Like I mentioned, the main thing we're going to be hitting is the basic concepts of knowledge graphs, reviewing sort of some of the modeling considerations and some of the technologies that are involved with that, defining what exactly an ontology is, and then finally that notebook, and then we'll hand it off to reKnowledge. So what is a knowledge graph? And this is a good question, and something that you're going to come across a lot with knowledge graphs in general is that there are multiple definitions. There are multiple definitions for most of the concepts and keywords throughout. So I've got a couple here, and I think it's just important to keep in mind, it's more about the base understanding of really what's the purpose of it. So a basic definition of a knowledge graph is that it collects the data from multiple graphs and attempts to implement a uniform ontology, making the graph data more accessible. This one I liked because it hits a couple of the points, which is you're pulling data from multiple sources, and you're trying to make that data conform to this ontology so that it is more accessible. More accessible meaning, typically meaning like more machine readable, so that you can start actually inferring new data from all these different data sources. And an even more straightforward one, this is from Wikipedia, where they actually have a list of definitions for the knowledge graph. And a network of entities, their semantic types, properties, and relationships. And I think that is a really good way to summarize it. It's a network of documents, in our case with the graph database, and then their semantic types, properties, and relationships, sort of defining how this data is connected. So why knowledge graphs? So I kind of just went over that, but more so like the goal being to make this data more accessible, typically with a focus on accessible to machines, more machine readable, and with the end goal of inferring new data from that data. So when I say inferring, I'm talking more about like the ability to look at a bunch of potentially data in Wikipedia and answer a question, or let's say maybe take a look at the use cases like natural language processing. So being able to do this question answering that says, you know, how many buildings are this tall over the entire world? And the ability to uniformly query data to find those answers. And another example would be an enterprise knowledge graph. This is where you might have multiple different areas within a single business and multiple different departments, and you want a higher view of looking at all of the data that's flowing in this enterprise to try and discern new information that might be useful. And then additionally going one step further from there, which is bringing in external information and adding it to your company's resources to help you with decision making. And additionally, with Customer 360, this is sort of tying back to the recommendation engine sort of idea where you go one step further with the customer information that you have. You can now bring in other info from other resources that will help you, help you or your customer decide different decisions that they might need to be making, or recommend different things for them. And then compliance is a big one that will be coming more often with things like GDPR. You've got to have awareness of anything that has any potential customer information on it. And you have to have the metadata that says if this customer one day wants to remove all of their data, you have to be able to show that you have verified, regardless of where this data may exist, that you have secured it and successfully deleted it or done whatever change was requested. Just another potential use case. And there are many different use cases from there for knowledge graphs as well. The main one that we're going to be looking at is the semantic web. We'll be looking at Wikipedia, Wikidata, DBpedia, but the idea that structuring the data for the web in this uniform way to do the stuff that we've talked about, and these bullet points are actually from this link that I've provided for the semantic web standards, and they cover what these mean in specifically to the semantic web. So having this link to data, and then having the vocabularies that define what these links are and what the relationships are within the data that exists, and that this ability to infer new data, and of course with a big goal of making this data queryable so that it's actually usable and you as the human even can query it. And then the vertical applications is more referring to new businesses trying to find new ways to work in the semantic or sort of knowledge graph use case in their environment. Okay, just going to real quick here. I know I'm kind of going a little fast there, so I'll try and back it off a little bit. But if anybody has any questions, do feel free to post them in the Q&A, and I'll try and keep an eye on that as well. Okay, so this is the example that we'll be working with. This is a snippet from Wikidata. This is Sir Arthur Conan Doyle, who wrote Sherlock Holmes. And I wanted to look at this one just to really start getting a higher level view, and then we'll zoom in a bit more. This is a similar view to something you might see on Wikipedia, but just set up just slightly different. And they're broken out into statements. And that's what Wikidata calls these little sections of information. And that first one up here, the instance of human, we'll see something similar to this when we look at the DBpedia dump and how that looks like. But let's take one step further down and we look at the reference for that. And this shows that this was imported from the Wikimedia project of the Russian Wikipedia page. And the reason I wanted to point this out is this is sort of that benefit of a knowledge graph, where we're taking information from multiple resources, collecting it, making it conform to this ontology that Wikidata has, and making it now accessible to hundreds of other sources, at the very least, other Wikipedia pages. And so that makes this data exist in a multilingual knowledge graph that is Wikidata. And this is sort of it in action, this back and forth ability to just improve the data for multiple resources. And just to take a quick sidebar there as far as the differences between some of these things. So Wikidata is going to be a knowledge graph where Wikipedia is an encyclopedia. And some of the flexibility requirements there go to Wikipedia, where you're having more human interaction. The data that may have existed or may have been necessary yesterday may change. And so you may have a new field you need to add to a Wikipedia page that you've never needed to add before. But you need that flexibility there in order to be able to add this data, this new information that maybe somebody figures out for some resource that didn't exist or wasn't defined in an ontology or a vocabulary definition. And going back to Wikidata, there needs to be this structure there that the data conforms to. And so there's just a little bit of a different motivation where Wikipedia is trying to present data to humans, and Wikidata wants to take that data and make it easier to process for machines. And we'll take a look at some of the ontology and discussion on what this conforming looks like in just a little bit, but just wanted to give a quick look there. And then taking from Wikidata to DBpedia, both considered knowledge graphs, whereas Wikidata has its own sort of schema that it developed, and DBpedia is derived from OWL, which is the web ontology language, which we'll look at in a second as well. But that's it's derived itself from sort of more of a standard, and Wikidata also has its own sort of customized model, whereas DBpedia is directly RDF based. And DBpedia had the primary goal of aligning to that semantic web, wanting to make this data that exists on Wikipedia and Wikidata fit this uniform structure that the semantic web was aiming for. Okay, now some of the modeling concepts are going to be RDF, XML, triples, and OWL. We're going to cover these in a quick kind of basic overview as well, but these all are also what make up working with knowledge graphs. You're going to, this sort of a combination of these things depending on how you end up using it. And we'll see a bit more what that means in a second here. The first one I want to look at is the resource description framework. And this is the core structure of the abstract syntax is a set of triples, each consisting of a subject, a predicate, and an object. That is a snippet from the RDF standards page. And that's what we're going to cover next, is the subject, predicate, and object. This triple concept is really, really prominent throughout knowledge graphs, and this is the first step in defining how data is processed, is agreeing on what the data model and then the serialization of it from there. Okay, and so now for the subject, predicate, object, we're going to look at still Sir Arthur Conan Doyle, but this is from the dump from DBpedia. And we're going to look through what makes up the statements and some of the different things involved when working with triples. So the first thing is an RDF resource, and I'll just read this. A resource may be a part of a web page, a specific HTML or XML element within the document source. A resource may also be a whole collection of pages, an entire web page or website, or a resource may also be an object that is not directly accessible via the web, e.g. a printed book. And I wanted to include that because as we look at some of these resources, it's easy to see them as URLs, but the benefit of a knowledge graph is not purely just linking to various web pages. A lot of it is trying to catalog, or the entire purpose of the knowledge graph that you're working on may be to catalog information that's not directly available on the web. It just is this idea of creating this uniform structure that when you add data to it, it can be processed. And then you can continue adding data and updating data, knowing that all of it is almost aligning to this schema of sorts that says this is what the data looks like, and these are the definitions for the relationships between the data. And so this is just a quick review of what a URI, IRI, or URL, the differences between them are. You'll typically, when looking at a knowledge graph, see URI or IRI as what the URL looking things in that statement was. But for us, I think pretty much in every case, they're also functional URLs, so that you can navigate to. So for our first one being the Arthur Conan Doyle DBpedia resource, and you can actually navigate to this one. It will take you to a similar looking snippet, a bit more familiar, like almost like a Wikipedia view of it that contains all the different properties and information over Arthur Conan Doyle. And this is the subject. And so as you see, we've got the three different fields here, the subject, predicate, and object, where the predicate is this is the actual just definition for what a predicate is in a sentence, the part of a sentence or clause containing a verb and stating something about the subject. So this is the connecting piece that says, what is the subject of this statement to our object, which is this third one here. And for our situation, it says Sir Arthur Conan Doyle is connected via, it's a type. And this type is defined at this URL here. And we'll actually take a look at this because this is tying into the ontology. This is referencing a definition that has been defined already. And that is a key pillar in knowledge graphs. And lastly, our modeling is the object, and this is the item the subject is acting upon or relating to. So this first statement is broken up into has three resources, and it's saying Sir Arthur Conan Doyle is a type of thing. And these are all, the type and thing are already defined, so we know exactly what we mean by when we say that. And if you look at some of the other ones that follow, person, artist, writer, so we know when we say someone is a person, that person has predefined properties and classes that they conform to. So we always know what we're looking for. There isn't going to be different definitions for a person because this person has already been defined, this one by DBpedia. And finally, actually the in statement. This is a period here, depending on the method that you're using to serialize the data, you can use multiple different things at the end of the line to either continue adding more information about the subject, or you can just say that's the end of the thing I wanted to say here with this period. And okay, this is just a quick review. So yes, the subject, predicate, object, Arthur Conan Doyle type of thing. And here's a couple of the popular serializing methods for taking RDF data and making it readable like that. We were just looking at an NT style, and I think that's what we'll also use in the notebook. But you'll see a mix. XML, I would say, is probably, it's very common with RDF, just because that's just a very accessible method as well. But I think equally common is TTL or NT. But it just depends on your use case there. Okay, and now we're on to the ontology section. This is another thing that you're going to find a lot of definitions on for what is an ontology, what makes up an ontology, and I've got a couple. I think I've got at least 2 definitions here for it. First, vocabularies are used to classify the terms that can be used in a particular application, characterize possible relationships, and define possible constraints on using those terms. This is directly from W3. They refer to it almost exclusively as a vocabulary on this page regarding their ontology. And depending on who you ask, that is a good or bad way to look at it, but W3 is kind of the resource on that. So I typically will take their word. But looking at Wikipedia, very similar definition, just some small changes. In computer science and information science, an ontology encompasses a representation, formal naming and definition of the categories, properties, and relations between the concepts, data, and entities that substantiate one, many, or all domains of discourse. So sort of a different view, but same thing, which is naming and defining the resources involved. And so for us, looking at the Arthur Conan Doyle example, naming and defining when we reference something that says this thing is a type of something, what is a type? What is a type attribute there? And then what is a thing? Once we say, okay, it's a type of thing, what makes up a thing? These sort of abstract ideas that humans don't have to actually define in their heads. We need to define that for machines so that they know what they're dealing with and they're able to begin inferring data from there. The ontology that we'll be looking at and is a very popular ontology is the OWL, the web ontology language. And it's more of something that's built on top of things like RDF and XML and a combination of other technologies to allow it to represent and build this vocabulary of things that's used throughout the semantic web. And definition listed there. This is directly also from W3. And that's, if you'd like to continue more on that specific side, you'll get the slides with this as well. So this is what you would see if you go to that URL that we had for, or I should say URI for the Arthur Conan Doyle example. And this is whenever we've been saying definition and defining what things mean, this is it. And if we look at the structure of this, we have the first thing is OWL. So it's referring to the OWL definitions of what a thing is. And then further going through using RDFS, which is another technology that aims to define things and sort of set up this schema for how to model data using RDF. And so this just provides more information on what exactly a thing is. And as you can see, the class of OWL individuals. And so if you navigate to this URL, you'll see a bunch of other definitions as well, defining exactly what makes up some of these abstract concepts, and all the way down to things like what makes up a person or a writer and these different professions. So I definitely recommend, this is something it's worth exploring on your own to start getting a better example. But this is also sort of an example of looking at something formatted closer to like an XML style formatting. and you'll see it looks kind of noticeably different from our previous triple example, but it is still following the RDF framework. Okay, well, we kind of zipped through that. And so the last part of this was the notebook that I talked about, where it's a very quick and just easy way to try out working with a triple, and then furthermore, getting that into ArongoDB. And I'm just going to pull that over here and just show a quick example of what I have, and we'll go ahead and run that. This is not the one I wanted. Okay. Here we go. So this is the repo that it's currently in. And if you'd like to try this out for yourself, you can come here and run the Colab notebook. And then if you do run it and you find a different method for importing this data into ArongoDB as a graph so that you can explore it in a more natural sort of property graph style way, definitely put that in the submissions folder. Or even if you just want to use this template and take a look at the DBpedia dump and try and find a different snippet and just show your basic understanding of how triples work, you can submit a PR against this repo, and that'll count towards your Hacktoberfest. But if you come here, you can open in Colab, and we'll go ahead and run all of these. And what's pretty neat about this as well is that when you run this, it's going to generate a temporary ArongoDB database that's only there for a couple hours, but it will generate the database, and it's a fully functional database. So if you just kind of wanted to check out ArongoDB, this is actually probably the easiest way to do it. There's no sign up or anything. You just can run this. It'll give you your credentials here for the database, and you can play around with everything. It's a fully functional enterprise edition database. And so what's happening here is we pull in those examples, that example snippet that I had here that shows our triples for Arthur Conan Doyle, and then we parse that using the, where do I show that? We use the RDF lib to parse that data. This just really, the main thing is just making it easier to work with, so that whenever we create our graph and the various collections, we can then iterate over the subject, predicate, and object involved in each of those statements and import them into our graph. And what I've actually done here is, this is just a quick sort of method for setting up something to show those connections in ArongoDB. So I've hashed the values, these URLs, and reason for doing that is just to kind of avoid dealing with any special characters, and it's just a consistent way to be able to query them as well. And then assigned them as in two different collections for subject, predicate, object. And there's a lot of different methods you could take here, such as creating collections for type. So you could say, I have a collection named type, and then I add different resources to the type collection. Yeah, I guess I would challenge you to try and find something that you feel like makes sense using triples. And this hopefully will at least give you a good starting spot. But let's take a quick look at what this looks like in the actual URL. And so this is what you can do if you did want to explore it. I need to move this out of the way. But you would go to the website that it prints out here, and then these automatically generated username and password here as well. And after running the notebook, you should see that you've created some collections here with just our Arthur Conan Doyle. And then you can actually explore that collection, that data here. And if you'd like a better look on it, there is a property called resource that just lists the URIs of the triple. And so you can see here, we're working with the Arthur Conan Doyle and its connection of type to person or thing or writer. And like I said, there is definitely different challenges as well that you face when you start dealing with different data, and maybe less. The benefit of using DBpedia is that it's formatted in a way that's a lot easier to work with. But I would challenge you just to try and play around with this notebook, see if you find anything interesting, and if you do, make a pull request, get yourself that one step closer to the I think it's 5 needed for the shirt. Yeah, and then of course, if you have any questions on that or anything, feel free to raise an issue or reach out to me on Slack. Cool. Okay, and this will all come around. You can, of course, access this repository immediately. I'll just quick paste this in the chat box, but then you'll get this information with the follow-up email. Go ahead and do the chat box now. Okay, well, I will post that actually next. Right now, that was actually all I had to show for that quick intro. And like I said, keep an eye out for the full tutorial that would come next. It's a written tutorial that goes in and actually explains a bit more of the stuff that we just got a quick look at today. So if you are interested, hopefully this is all just served to pique your interest a little bit more in knowledge graphs, what exactly that means, and then kind of continue exploring from there. Other than that, I will hand it over to the guys from reKnowledge. I don't know who is actually coming up first.
That would be me, Chris.
Excellent. All right, well, I will just let you take it over from there.
Okay. I think you need to enable me to share my screen. At the moment, he's telling me I cannot.
Okay, I'll change you to host then. I think that'll be the best thing. And we can go with that. There you go. You should be able to change and do everything now.
Yes, indeed. Excellent.
Awesome. Okay.
Cool. Well, thank you very much for having us, Chris. So I'm Julian. I am the CEO and one of reKnowledge co-founders, along with David Costa Fidela, who is our CTO. So the tool we are developing is designed to improve the efficiency of complex investigation, like political and binary risk forecasting, due diligence, asset tracing, academic research, and so on. And typically, this sort of investigation requires the researchers to gather a lot of discrete pieces of evidence. It's also required them to track a lot of different sources coming from all over the place. And more importantly, they need to manage huge amount of body of evidence. And right now, the job is done very much in an old-fashioned way, with analog technique like investigative board, mind mapping, and note-taking. And so the solution we have developed is designed to streamline this workflow and allow analysts the benefit from leveraging technology to store and query the knowledge. Because as you showed earlier, there is a need to encode information so that the machine can understand. And with reKnowledge, we make this much, much easier. And I'll show you how in a second. So the tool has three key features. First of all, it has a customizable ontology where the user can define how to organize the knowledge. It has an analytical workbench to visualize and investigate the knowledge they generate. And finally, we've developed a web browser add-on to collect and consolidate data and information from online web pages. So to start with, the users can fully customize the ontological architectures of the knowledge base. And they do this by defining the sort of node classes they're interested in. They can also define the sort of attribute they want for each of those node classes. And then every single of this customization will propagate into the whole system so that the scorecards of the nodes will reflect that particular architectures, and as well our advanced search tool will reflect this information architectures. And the architectures is also deployed in our mouse wheel tool, which I'll show you in a minute. So user can define what sort of nodes they're interested in, but they can also define the sort of relationship they're interested in. So they can create a relationship that matter to the analytical purposes. They can define what sort of node classes those relationships will apply to. And again, they can define the sort of attribute they want. And once they've set up their the knowledge base, effectively building up the infrastructure of the information, then they can start filling up their database. And to help our user gather and consolidate information online, we've got our little web browser add-on. And the way it works is that it allows users to overlays and interact with the known knowledge on any web page. So any individual or entities or events or location that we already have in the database will be overlaid every time it's appearing on a web page. And then the user can interact with this information, can add new information, it can create connections on the web page and so on. But obviously this is not the feature you'll be the most interested, so I won't go into too much detail for this. And then finally, we have our analytical workbench. And this is where people can navigate and investigate the knowledge, and they can do this in an iterative manner by seeing what sort of nodes are connected to each other. They can also investigate the various scorecards, so they can open the node and connection scorecard to see what sort of extra information is available. And finally, they can customize the graph in order to make it more understandable. But really, the power of knowledge graph is, especially in reKnowledge, is that behind the scene, all the information is very much structured. So now we can start running much more advanced queries. And this is what I'm going to show you next. So the advanced query tool we have developed, something we're very, very proud, because it was designed for domain experts that have very little or no technical skills. So the way it works is that we have little puzzle pieces that the analyst can put together to create logical queries. And this is a way of building very complex queries in a very intuitive manner. So right now, what I'm looking at is for companies that are being banks. And next, I will ask to see who are the client of those banks. And just for context, this is following the FinCEN file leak, which was published by BuzzFeed a few weeks ago, which highlighted a lot of fraud and suspicious activities by many clients of mainstream banks. So right now, the queries I'm building is effectively asking for any entities or individual that are client of a bank. And once I've built my query, I can just run it, and the system will return the matching data. So here are all the various clients of banks we have identified in our research. But really what I'm interested in here is to understand of all those individual entities, I want to know which one are being sanctioned by some regulator. And again, I can amend my query to ask for any sanction connection to any entities. And once I'm done, here we go. Now I can run this query. And my graph updates with the new information. Now, to make the graph a bit more understandable, I'll just customize quickly the connection and highlight the sanction connection in red. Here we are. And now we can start identifying some potential red flag. So if I'm HSBC, having Vida Panama as a client is a red flag because it's an entity that is directly sanctioned. But really what's happened in the real world is that often the sanctioned entities are not directly banking with the banks. They're using intermediate individual entities to hide their activities. So now this is what we want to try to find out. Are there any banks clients that are not being sanctioned by anybody, but that have connection to sanctioned individual or entities? So now, again, I'm modifying my query. I add an intermediate step, and I can run this query. Here we go. And now again, the graph has updated, and now we can see some new information. So here, typically, the Well Fortune HK wasn't a red flag initially because it wasn't directly sanctioned, but because its owner is under sanction, that then should raise a red flag. So that's how typically our users are using reKnowledge by first gathering discrete pieces of information from all over the place, thanks to the web browser add-on, and then they can navigate and find insight in this knowledge gathered with our analytical workbench. So one of the way they have found the insight. Oh, sorry. But with our tool, research organizations are also building up an institutional knowledge that they can leverage again in the future. Any data or information gathered in this project will be available to researchers in any subsequent project. And this, again, is something that doesn't really happen at the moment, because the way researchers works is that they work on a project, then they file away all this research, and it's never been accessed anymore. But because everybody works from the same knowledge base, any data, any information added to it will remain there forever, or until it's modified or updated and so on. So in short, we are making, reKnowledge is making complex investigation much more efficient, traceable, and data-driven. And it enables our client to develop a reliable and constantly evolving knowledge management system. But we also believe that our platform is very much democratizing the use of knowledge graph by making it available to people with little or no technical skills. And now David is going to go into the more technical aspect of the platform and give you a little bit of overview of how it works behind the scene.
Thank you so much, Julian. Chris, am I ready to share my screen?
One moment here.
Yeah.
There you go.
Am I sharing?
Yes.
Brilliant. So thank you very much for having us, Chris and the guys at Arango. And first and foremost, as reKnowledge, we're very thankful that you guys have developed this piece of technology. So I'm going to spend the next few minutes talking to you a little bit of the challenges that we have as reKnowledge with the type of product and platform that we're building, and how Arango has helped us to go through this journey. So without further ado, let me tell you a little bit of reKnowledge. We're a very young company. We started around a year ago, mid-2019. Julian and I didn't know each other, and we met through a startup accelerator called Entrepreneurfest. And although we come from very different backgrounds, we were bounded by a shared obsession around information architectures and making delightful products that really make professionals' life easier. And I personally have a background in trying to build magic things that hide a lot of the complexity of what technology has to offer for the layman. And having said that, we set up our objectives as follows. So we wanted to create a platform and a product that fosters and helps human-machine workflow interactions. This is what we've been discussing and Julian has been presenting. All these analysts that are doing complex investigations, they not only need to be able to gather information quickly, but they need to be able to make sense of it. They need to be able to analyze it, and it needs to be ready for machine consumption. And this is a symbiotic relationship. And there is another aspect when we talk about knowledge graphs, which is not only, when we talk about knowledge graphs, we normally talk about static views of knowledge graphs. But the reality is that the more information we get into our systems and the more temporal information and dimensions we get of that information, that changes our graphs, that changes our assessment, that changes our analysis. So what we are aiming with reKnowledge is how we simplify and streamline this management of all this data that becomes information, that becomes knowledge, in a way that it is an alive feedback loop, a feedback loop that allows us to understand what's happening and use it. As Julian said, a consequence of doing what we're doing is that we expect to help with the democratization of access to knowledge graphs and in general with knowledge analytical tooling. And the way that we're doing this, as you have seen in the demo, is by developing software toolings for initially targeted for intelligent researchers and analysts, but more broadly, because of how we have approached our platform and what Arango has allowed us to do, create a truly vertical agnostic baseline to build any sort of domain-specific analytical tool. So what are our main challenges? We want to do this at scale. So our customers have very different profiles. So our get-go challenge was how do we build a platform that grows with the need of our customers and supports different models, both of permissioning of what data they can see. It's not as much of how we integrate the data, which is an area of reKnowledge that we are obviously working on around whether it would integrate in RDF or with existing proprietary databases and how we unify those models, but simply, how do we provide a team of researchers and analysts with tools that allows them to A, have the systems with infrastructure that they require, and B, implement permissioning levels with the highest levels of security, resiliency, and performance. Equally, because we allow our users to define and our customers to define their own ontologies, how do we build a system that scales and evolves and allows the validation and the structural validation and enforcing of the data models that are there to verify and guarantee data integrity? And as I said, reKnowledge as a bare bones, it is completely vertical agnostic. Now, because we are serving the intelligence community and the analytical views, it is as much about the tooling that we give them, but also the visibility, auditability, and traceability of what happens in the system. So it is as much of the data that we have in, but also who can look at it, how are they looking at it, who is editing, when are they editing. And an additional dimension to that is data evolves over time. So the graph that you have today, with this new nugget of information that you've done in a relationship hidden into a subgraph, how does that affect your analysis? How does that allow you to evolve? So what we wanted is to make a first-class citizen of our knowledge graph, the concept of temporality, and being able to evolve those analytical graphs and those knowledge graphs over time. And we want to do this without having to expect our users to know or have any technical skills. We're not, this tool, the surface of the tool is for people that are not software developers or data engineers. Now, how have we achieved what we have achieved? Well, there are a number of areas of why we've achieved this, with a lot of sweat and tears. As I said, we're a very young company, very small team, so there's been a lot of sweat and tears. And what's really helped us keep our feet on the ground has been the hyper-focus. Just really, really focusing on our eyes on what we were trying to achieve and how. It helps that we've got an extraordinary vision and a really capable team to implement the solution. But it also helps that we've had a huge dose of pragmatism in how we have gone about things. And I can tell you for the next 2 hours other characteristics that we may have required in order to achieve what we've achieved. But there is a key element to all of this, especially from a technology point of view, which is that you need to make the right technological choices. And by this, I'm not saying that I already decided a year ago on an infrastructure that's going to be with me forever or with reKnowledge forever. But what I knew I wanted to do a year ago, combined with the immediate next steps I wanted to do, the process of technology selection encompassed the criteria of, okay, can these tools do what I want to do today? Can these tools do what I know I'm really going to try to do? And if the answer to those questions is yes, the third question that I asked was, how many doors am I going to close by going with this technology versus that technology? And what informed the decision criteria of going with Arango was that it closed pretty much no doors. So it opened us a world of possibilities and flexibility. And this is, I'm not going to be talking only about how we're using Arango for the Arango intrinsic models of data and relationships, but how as a platform, it really empowers what we want to do. So let's talk a little bit more and let's get a bit specific, right? So when I talk about growing with the needs of our customers, there are a number of dimensions. Let's start with tenancies and users, right? We want to build a system that helps with one single user working on their desktop at home. Or we want to work with a small company that's got a couple of different data right profiles to explore and modify data on a small company that they work remotely, collaboratively, and maybe they have an internal deployment. And then if we take it to the next step from the individual user to the small company to a big enterprise, then you're dealing with, well, now we're talking about customers that are going to have a lot of users with a lot of roles, with a lot of different permissions in there, with a lot of auditability and traceability, legal requirements, and that also have very, very different data requirements. A single user or a very small company is very likely that with very little infrastructure will get the performance and they need what they want. But when you start looking at enterprise customers and you start looking at aggregating parts of their data sets in order to bring the power of knowledge graphs, then the situation changes dramatically. And on top of that, given that we want our customers to be as platform agnostic as possible, and by that what I mean is that we know we have customers that want to run things on their desktops independently of their operating system, but we also know that bigger customers and enterprise customers want us to run things on either their own cloud or on our own cloud, multi-tenant cloud. And of course, everything in between around virtualizations with OpenStacks, Dockers, and Kubernetes that you can imagine, to do hybrid models, to do on-premise, to do on the cloud. So how do we achieve this? And why is Arango really making a difference for us? Well, if we just look purely at how we can instantiate the concept of a database in Arango, we can support the models of one customer or multiple customers by simply changing how we deploy Arango in terms of a single node server versus a cluster. And if we're looking for multiple customers with multiple users, we can envisage a multi-tenancy model in which with a big fat Arango cluster, we can actually create those databases that are essentially virtual verticals that isolate the data from one to the other customer. And on top of that, we layer the ability that we've got with Arango to configure different topologies. And then we can really fulfill the requirements around data and process and what's the word now? We'll move on. Additionally, Arango ships with multiple editions. So we can run it natively on Windows, on OS X and Linux, or we can run it in cluster configurations that are either customized by ourselves, deployed wherever we want them to be deployed, or we can use your Arango's commercial offering around Arango Enterprise and Arango Oasis. And that helps us a lot to plan for the future. Now, if we get a little bit under the hood, Arango has also another module called Fox, which is a microservice layer that ships with it. And this surprised me a lot when I saw it for the first time. But when I started looking into it, I realized that, well, I can create a lot of complex logic and expose it via a compatible REST and OpenAPI way that is directly integrated with the database. And that really simplifies the infrastructure that I need to provision in order to really deal with the scalability of the system that I know. So this is a small snapshot of what part of our internal APIs look like. And that has been done with Fox microservices. When we combine that with how we can actually configure a cluster in terms of how you can organize the topology in terms of coordinators, agencies, and servers, that allows us to keep our data-intensive logic as close to the database as possible, but also to distribute our loads optimally, to optimize the performance of our system, and ultimately leverage the internal user authentication and session control that Fox already offers to provide a base to implement what our multi-role, multi-permission access levels look like. Another part of the Arango family of products that we're using that is also integrated with ArangoDB is Arango Search. So because we are dealing with lots of different data sources and documents, it's very important that we can make them available as fast as possible. So by using Arango Search, which is akin in my mind to tools like Elasticsearch, we can really define our analyzers, tokenizers, and support full text indexation and fast retrieval across all our corpuses of data. And it really is a breeze to work with. Now, another element that is critical at reKnowledge, as we have seen in the demo and we've discussed before, is that we allow our users to define their own ontologies. And we're building a system that allows you to go from a very, very simple ontology with a couple of types of nodes with maybe no relationships or a couple of relationships and no attributes to something hyper complicated that represents really, really deep ontologies, really deep relationships with very deep models associated to both the nodes and the relationship that you're going to be dealing with. On top of that, as Julian demonstrated before, we want that these alterations on the ontologies that we do, we want them to surface through our product. We want them to be directly available on our web add-on when a data collector is doing work online. And that reflects also on the little scorecards that represent the nodes themselves. Equally, that is a companion when we're dealing with the workbench analysis features, and more importantly, for our advanced search features. And how do we achieve this with Arango? Well, Arango allows us very easily to define new collections on the fly, to index new data dynamically on the fly, and to allow our customers to evolve those data models and data relations dynamically and help them evolve them over time. And by using fogs again, we can very easily implement strict modeling, versioning, and validation. So we can guarantee the structural integrity of the data that comes on the system, that it is compliant with the models that have been defined or imported from external sources. We mentioned as well that a critical part of reKnowledge is as well to have full visibility for our customers on the audit trail and the time machine that allows us to travel back and forth in the different business time snapshots. So it is imperative that we support data versioning and provenance, that we make it very easy to visualize and to understand audit trails on data access and data operations. And as I mentioned before, we want to be able to see at the lowest granular level how our data evolves and what state our data was at different points in time, because that matters when we plot graphs and when we do analysis over time to understand what things have influenced our criteria and our decision making. Again, by using Fox microservices layer, we have been able to implement our proprietary information models and processes that really very easily encapsulates and hide all that complexity and allows us to perform that data timestamping and data access completely transparently. And all of this, as I said, thanks to the topology of Arango, allows us to keep all this processing and all this logic as close to our data as possible. Now, as we've seen, by definition and by design, reKnowledge is designed as a product and as a platform that is domain-based. We don't expect our customers to be deeply technical, although obviously there is advanced feature that can be looked under the hood for technical users, but in general, we're targeting a demographic that are not technically savvy. So we want to enable them to perform that timely analysis, that really deep introspection of data, and visualize and understand what's going on and be able to communicate that insights without any technical knowledge. And this speaks to what we've done with our advanced query sites that Julian was showing us. For example, in here, we're seeing on a specific data set, we are interested in seeing what individuals may be connected between what's in between Eric Prince and Donald Trump in a certain dimensionality around business or financial relationships. And the system allows us to do that at different levels of depth. So we can actually change how deep we want to go into the exploration of the network. Another example is what Julian presented of the sanctioned banks. Another one in this case would be a little project that we did tracking countries implementing different coronavirus and adopting different coronavirus policies. By using the time slotting, we can actually see how those countries and their policies have evolved over time. And when we connect that with actual success and death rates, we start having very, very interesting information. And we start having very interesting conclusions of what policies should have been adopted earlier and what policies did work versus which ones didn't work. And how do we do that? In this case, we're going to talk about the Arango query language, which is a little bit, Chris showed that when he was showing how we are going to import data from RDF. So we're using that at scale. So we have created a visual interface that allows you to deal with domain concepts, business concepts, but that internally translate that in the simplest possible way into hyper complex queries that allow us to introspect the data as we require and obtain the result that we're looking for. And this is more possible even because of Arango being a native multi-model database. So it's not only about nodes and relationships, but about all the document models that we have. And we can leverage all of that to create as complex queries as we want with the dimensionalities that we want. And we can do that easily and natively. So really integrating this has been a key feature for reKnowledge. When we look at our future roadmap and development roadmap, machine learning is going to play a very, very important area for us. And that's going to be around the introspection and providing proactive and predictive reasoning over complex graph networks. And we have no doubt that Arango machine learning will play an important role. We've started doing some little prototypes, and we think that this is the way to go, and we're definitely all in with this. And in terms of reKnowledge, that's pretty much all I had to say. So I just want to do a few closing remarks here, which is that as reKnowledge, we've had a really, really intense first year. And having had ArangoDB as our companion on the Arango team has been a godsend. Has been a godsend because we know that this platform can do what we need it to do, and we know that it stays with us and it will help us in our journey. And this is due to both the technical awesomeness of Arango, but it is also around the diversity and the catalog of the offerings and the features that it offers. From Arango Search to the Fox microservice layer. It's as an open source initiative. This has done something that is critical at any early stage startup, which is you want to have as little technical debt as possible. I won't claim that we don't have any technical debt, but I will say that I would have much more technical debt should I have made a different technological choice a year ago. And with that, I leave you all with a big thank you to the Arango team. And of course, if you're interested in what reKnowledge is doing, please do get in touch and feel free to download our digital investigative board in our marketplace. Thank you so much.
Awesome. All right. Thank you. Thank you both. That was a very interesting one. And I'm really immediately surprised with the amount of features that you were able to take advantage of. It sounds like within just your first year. So thank you very much for sharing.
It is a really well-engineered product that ArangoDB. I mean, that was a godsend when I found it. I was like, okay, if this can do what it says on the tin, this is going to help us a lot. And so far, it's proven that on every step of the way. And it's not only been the product itself; it has also been your team. I mean, all the guys that you've got on your public Slack channel, they're so incredibly responsive. I mean, the community that you've got there thriving is amazing. It truly is amazing. So thank you.
Yeah, hey, thank you for the kind words there. That's awesome to hear. And yeah, like I said, I'm also just really happy to see one application of so many different features. And personally, when I came on as well, I was pretty blown away with just Fox and how easy it was to get started. And I use it all the time for just little things. If you have a small task you just want to get done, it's the go-to for me. So that's awesome.
Brilliant.
All right. Well, I don't think we have any current questions available. If anybody in the chat has any questions, now would definitely be the time. Otherwise, we are going to send out a recording of the video. This will show up on our ArangoDB YouTube as well. And then the slides that I presented will go with the email. And actually, for those still in the chat, I'll do a quick post of the repo that you can make a pull request against once you're ready to get you one more PR for the shirt for Hacktoberfest. That'll be included in the email as well, though. All right. Well, I think other than that, David or Julian, any other remarks from either of you?
No,
It's very
no.
instructional because as a company, we are looking at a number of data integrations now. And the intro that you did to the RDF and the OWL, yeah, was very interesting for many reasons. So thank you for that.
Excellent. Well, I appreciate it. And thank you both for joining us again. And that was an awesome presentation. So definitely check out reKnowledge. Otherwise, thanks everyone for watching, and hope everybody has a great rest of their day.
Thank you, Chris.
Bye.
Thank you, Chris. Bye-bye.
Bye now.